Hi, everyone, and welcome to Into the Blockchain with Progress. If you've ever heard about Web3 and you were confused or you thought it was too complicated to understand, this is the right place for you. You do not need any prior knowledge because I'm going to be breaking things down step by step so that you understand not just what Web3 is, but you get to know why Web3 matters and how it's changing the way we use the internet. So think of this space as your safe space to explore, to ask questions, and to really understand Web3 from the ground up. This is class one, and today we are starting from the very beginning. What is Web3? But before we continue, just say these affirmations with me. I am curious, I am capable, and I can understand anything I set my mind to, even Web3. Every step I take in learning opens new doors. Today, I step confidently into the world of the blockchain. All right. But before we jump straight into Web3, we need to take a few steps back because to really understand where we are, we need to see how we got here in the first place. Every few decades, the internet changes. At first, we could only read the internet in Web 1, then we learned to interact with it in Web 2, and now we've entered the stage where we can actually own parts of it. That's what Web 3 is about. It's the next evolution of the internet. But before we understand Web 3, we need to get back to where it all began. So I'm taking you to the beginning. Our story starts in the 1960s with something called ARPANET, that's Advanced Research Projects Agency Network. I know it's wordy, you don't need to get all of that, but ARPANET. Now, ARPANET was a pioneering computer network funded by the US Department of Defense. Think of it as the first successful attempt to make computers talk to each other over long distances. ARPANET introduced something revolutionary called packet switching, which made everything faster, more reliable, and decentralized. I'll explain packet switching in the next slide. ARPANET also implemented the TCP IP protocol. TCP IP stands for Transmission Control Protocol Internet Protocol. It's basically a universal set of rules that lets computers communicate across different networks. That's the backbone of what we now call the internet. I'll also explain that as we go. Now, packet switching. Before packet switching, communication systems send data in one continuous stream. Now, if the connection broke, everything stopped. One line down and the whole connection, the whole conversation failed. See, think of it like this. Imagine you wanted to send a letter to your dad who lives in a different city from you. If you give that letter to a friend who is going to that city, right? If anything happens to your friend, the letter will never get to your dad. That's how everything works before ARPANET. But with ARPANET, what happens is this. You want to send a letter to your dad in a different city. Instead of giving that letter to just one person, you give parts of the letter to different people. So if anything happened to one of those people, parts of the letter would also get to your dad. Now, even though all of the letter don't get to him, those parts that get to him can also make sense. I don't know if you understand this. Now, packet switching was simply data broken into small packets. It was sent separately through different routes and it was reassembled at the destination, just like we have with the little video to your right. You see, host 1 wants to send a message to host 2. Host 1 wants to send the blue, green, and red blocks to host 2. Instead of sending these blocks just through node 1 or just node A, just one node, the the data packets, the message is sent through different data packets, and these data packets take different routes to reach their destination, host 2. When these packets get to host 2 reassembles these packets and gets the original message. Now, what packet switching did was it made the communication system faster, it made it more reliable, and it made it more decentralized. Decentralized means that control is not in a single place. Control of data, control of information is not in a single place, but instead it's spread across many points. Just like I said with the analogy of sending a message to your dad. Now you see that the data, the message, that information is not with just one person, but it's spread across different people so that the message, that information can finally get to the host. This principle of decentralization is one of the key ideas behind Web3 today. We'll get back into that very shortly. The birth of the internet. Technically, the internet as we know it was born in 1983. The internet is simply a global system of interconnected networks where we have billions of computers, billions of servers, and billions of devices all linked together. The internet has both private networks, public networks, we have academic networks, we have government networks, and they all use TCP/IP, which is the same language, to communicate. I'll explain what TCP/IP means in the next slide. Like I said earlier, TCP/IP simply stands for Transmission Connection Control Protocol and Internet Protocol. Transmission Control Protocol, Internet Protocol. Now, the internet is not one single network. It's what we call a network of networks. It's multiple billions of networks connecting, billions of computers, billions of devices, billions of servers connecting, right? I want to understand what TCP/IP, Transmission Control Protocol, and Internet Protocol mean. TCP/IP is the language of the internet. Think of it as the universal language that computers use to talk to each other. It's the set of rules for how data is broken down, how data is sent and reassembled across different networks. Imagine sending a letter around the world. Let's still use this analogy of a letter. Now you want to send a letter around the world. You know that around the world we do not speak the same language. In Nigeria we have different languages. In the US, English is spoken. In other countries, there are different languages that people use to communicate. But TCP/IP is that portal system that makes sure the letter gets to everybody, even if it takes different routes. And when it reaches them, it's complete and it's readable. They can all understand this letter. Without TCP/IP, without Transmission Control Protocol and Internet Protocol, billions of devices and networks could not communicate. The internet as we know it would not exist. Now, this makes networks interconnected and reliable, and it is the backbone of the modern internet. So far, we've understood what ARPANET is, how ARPANET used packet switching, how it used TCP/IP. We've understood the birth of the internet in 1983. And now let's move into Web 1. Web 1 is called the read-only web. Web 1 came about in 1988, and with it came the World Wide Web. With Web 1, users could only read content. Examples of Web 1 interfaces are like online newspapers or static pages. Now, with Web 1, you could visit websites, read information, maybe click a link, but that was it. Think of it like reading an online newspaper, like I said. You could only read this newspaper, but you could not comment, you can't post, you can't interact. It was just simple, static information. So you can only read, you cannot add anything to Web 1. You could not comment, you could not do anything else but read. Then we move on to Web 2. Web 2 is the read write web or the interactive web. This is the internet we've been using for the last 20 years. Web 2 gave us interactivity. It brought about social media like Facebook, YouTube, Instagram, X, TikTok, and the likes. Now, anyone at all who had access to the internet could create content, you could share your opinions, you could upload photos, videos, and you could connect with millions of people instantly. Web 2 is the age of user generated content, UGCs like we call it. It's the age of collaboration and global communities. But here's the issue with Web 2. Big tech companies started controlling the platforms. They started controlling the algorithms, the traffic, and even our data. They monetized the way we interacted online, often without us even realizing it. That's why you hear people say if you are not paying for the product, you are the product. Now, Web2 gave us the freedom to interact, but at the cost of control over our own digital life, right? Let's move on to the problems of Web2. Now, with Web 2, users interact, it was interactive, but users do not own their data. Big corporations monetize traffic and they monetize our content. They were in control. Web 2 is centralized. It's controlled by a single authority, is managed in one place. So Facebook manages all of the information on Facebook. You have access though to interact on Facebook, but you do not own your data there. Web 2 has less privacy and less transparency. Now that's why Web 3 came about. Web 3 came, the word Web 3 was introduced, the term was coined, it was introduced by Gavin Wood. Gavin Wood is one of Ethereum's co-founders. What Web 3 is decentralized internet. It is not controlled by a particular source, a particular person, or a particular corporation. Web 3 is not controlled by few corporations, right? Web 3 combines the decentralization from Web 1, like in the case of packet switching, it combines the interactivity of Web 2 and it adds something very powerful, which is ownership. Now with Web 3, instead of platforms owning your data, your identity and your content, you own it. Web 3 gives users more control, more security, and more transparency. And all of this is powered by blockchain technology, which we'll dive into as we go further. So let's just go over what we've learned today. This is the internet evolution at a glance. It started in 1960s with ARPANET. ARPANET introduced packet switching. Then we went over to the internet in 1983, which uses transmission control protocol and internet protocol for communication, right? And then in 1988, Web 1 was introduced. Web 1 is the read-only internet. In the 2000s, Web 2, which is the interactive internet, but it's centralized. With Web 2, we could interact, we could share, we could connect, but we lost control of our data. Now, Web 3 is here. Web 3 began in 2014 up until now. Web 3 is a new era where users can own their digital life. With Web 3, you take back privacy and you capture real value online. That's what Web 3 deals mainly with decentralization and ownership. In our next class, what's coming next, we'll explore what makes Web 3 different. We'll also dive deeper into we'll also really compare Web 3 and Web 2, and we'll get to understand blockchain technology. Thank you for staying with me up until now. Feel free to subscribe because on here I'm going to be sharing a lot of value, and also feel free to share with your friends and family. Bye. See you in my next video.